that it is important to know. When you have this big, long, expanded equation of a conic, what you have to be able to recognize is when you see that conic, these two terms right here, all you have to do is look at those two terms and you can determine whether it's going to be a circle, an ellipse, bless you, a hyperbola, a parabola, whether the parabola is up or down, whether the ellipse, whatever the ellipse is, vertical, horizontal, the hyperbola, all of those things you can determine by those two letters. So A and C are going to be the most important letters. When you look at the A and C, if A and C are equal, meaning both are positive and both are the same number, then you know that it's a circle. Okay, you don't have to actually do all of the completing the square of that. A and C, when you look at an equation like that, all you have to do is look at the number in front of the x squared value, the number in front of the y squared value. If they are the same, then it is going to be a circle. And so you see down here the equation of a circle. If you want me to go back and prove that for you later, I will. But those little three dots just mean therefore in math. So the equation of a circle is r squared equals, or this equals r squared. Doesn't matter which end the r squared is on. And you have x minus h, which is the x of the center, y minus k, and k is the y value of the center. If there is not an h or a k, it just means the center is 0, 0. Okay, you don't write 0. If there is a 0 involved, you leave it off. Okay, if you want to write it and then your final answer you don't write it, that is appropriate. But if you put x minus 0, that is considered not simplified, and just like all the other times, you're going to get a point taken off. So do not put zeros for the x and the y's, because I will consider that unsimplified. If someone else doesn't consider that unsimplified, it's fine, okay, but someone else is not grading your tests and quizzes. I am. So I consider that unsimplified, so don't do it, unless you want a point taken off. All right, so equation of a circle. We're going to do a lot of different things with the circle. So the first one, it's kind of like a word problem. It's not really a word problem. It's just given to you in words, okay? It could give you a picture, and it would be the exact same problem, just in picture form instead of word form. So this one's pretty easy, the easiest type you can have, where it gives you HK and it gives you R. So you plug that in the formula. X minus h, so minus negative 3 becomes plus 3. Y minus k, so minus 2 squared, equals r squared. So 6 root 3 is r. Some of you are still really struggling with squared, okay, squaring things. 6 root 3 squared means 6 root 3 times 6 root 3, which is basically 6 times root 3 times 6 times root 3, which is 36, the square root of 9, which is 36 times 3, which is 108. Okay? Whenever you square something that's in parentheses, whatever is in the parentheses is what you're multiplying by itself. You're not distributing anything. I mean, you could consider that distributed. 6 squared, root 3 squared, because there's not a plus sign. We can say that. If that was 6 plus root 3, then it would be 6 plus root 3 times 6 plus root 3. So multiply and add and subtract is completely different. So then this equals 108, and there is your answer. Notice the number in front of the x squared and in front of the y squared. This number right here in a circle, okay, when it's in its general or standard form, always has to be a 1. Okay? This number right here always has to be a 1. All right, here find the center and the radius. So this one's pretty much in standard form. We just need to bring that 28 over to the other side. So the center should be pretty easy to pull out of that, 4, negative 2. The radius, it's not 28, okay? R squared equals 28. When we take the square root, R equals plus or minus the square root of 28. We're talking about a radius. A radius can't be negative, so we ignore the negative. Can't tell you how many people are still not knowing that when you take the square root, it's plus or minus. You have to know that, and then you have to know when it matters, when it doesn't. Here it doesn't, so R equals 2 root 7. You always have to simplify. Always, always simplify. That had been r equals the square root of 30. Then it would have just stayed the square root of 30, because that can't be simplified. If it can be simplified, you must do so. All right, now this next one, we're going to have to complete the square. So that's going back to Algebra 1, you completed the square, maybe geometry, maybe not. Algebra 2, you completed the square, you're going to have to complete the square. So the first thing to do is kind of line up, get all the x's together, all the y's together. So we have 2x squared minus 28x plus 2y squared. There's no y, and you bring the constant to the other side. So with these, it's a possibility that you have to complete the square for the x's and the y's. In this case, because there's only a y squared and no y, you don't have to complete the square for the y part of it, only the x. So first thing to do is, if the leading coefficient is not 1, you have to factor that out. And again, we're only dealing with x's. X's and y's are separate. Do you have to go to? Okay. So we take the 2 out. X squared minus 14x. We complete the square by taking half of b and squaring it. Well, let's do that in a second. Plus 2y squared equals. So here, half of b and squaring it, so half of b is negative 7. Negative 7 squared is positive 49. We take half of b, square it, and add it to both sides. But if you factored something out, you have to multiply before you add it to the other side. Because we didn't really just add 49 to this side, we added 49 times 2. So we have to add 98 to the left, we have to add 98 to the right. So then we end up with 18. Negative 80 plus 98. All right, the whole reason for completing the square is so that you can rewrite it as a binomial squared. And what I said earlier, if you look at the numbers in front of the x squared and the y squared and the same, we know it's a circle. We know this is a circle because it's in the circle section. But on the quiz and the test, there's not going to be a circle section and an ellipse section and a hyperbola section. It's going to be conics, and you have to know what they all are. But this is not standard form. The number in front of the x and the y, if you're going to write an equation or find anything about it, needs to be 1. So you have to divide by that number. And you end up with x minus 7 squared plus y squared equals 9. Now, could we find the center from up here? Yes. Could we find the radius? No. So the center is going to be 7, 0. The radius, remember this, r squared is equal to 9. So r equals plus or minus 3. The radius can't be negative, so it is just 3. Now, if you get to this point up here and you can recognize, okay, I recognize what everything is. You don't have to go. It doesn't tell you to write it in standard or general form. It just asks for the center and the radius. So once you are able to find those two things, then do that. My suggestion would probably be go all the way, because if you stop here, you're probably going to say that r squared equals 18, and then you're going to solve for r incorrectly. Get it in standard form before you answer the questions. All right, we are going to be doing a lot of completing the square, so if you don't remember completing the square, you need to go back and look and try to do as many of those as you can, because there is going to be a lot of that involved in circles, ellipses, hyperbolas, parabolas, all of it. All right, find the equation with diameter endpoints 1, 5 and negative 1, 7. If drawing a picture is helpful to you, then do that. So we have a circle. We have the point 1, 5 and negative 1, 7. If those are diameter, it's not a very good circle, okay? But that means if we have a circle and we have diameter endpoints, that means if I can find the middle of that, it's going to be the center. Okay, the diameter, we need to know, goes through the center. So if we want to find the midpoint of the diameter, which is considered the center, we just find the middle of those 2 points. So we find the middle of the x's, the middle of the y's. So if one x is 1 and the other one is negative 1, we could probably look at that and figure out that the middle of that is 0. Or we add and divide by 2. 1 plus negative 1 divided by 2 is 0. What's in between 5 and 7? We can all look at that very easily and know that's 6. Or you add and divide by 2. 5 plus 7 is 12, divided by 2 is 6. So there's your center. So we know it's going to be x squared plus y minus 6 squared. Now we just have to find the radius. Now the radius you can't find just by counting unless the point that you're given is directly left, right, up, or down from the center. So if this is the point 0, 6, and let's say this is 1, 5, we need to find this distance right here, which is r, so that we can square it. Or you can find the diameter, divide it by 2, and square it. Whatever you want to do. Either way, it's fine. There's less work if you just find the radius, because you have to square it, instead of dividing by 2 and squaring it, but either way, it works the same. So I'm going to find this distance. So you have to know the distance formula. So r, which is my distance, is equal to the square root of 0 minus 1 squared plus 6 minus 5 squared. If you wanted to say 1 minus 0, that's fine. If you do 1 minus 0, then you have to do 5 minus 6. It doesn't matter which point is your first point and which point is your second point. As long as your first point is your first point and your second point is your second point. You can't flip-flop them, okay? So 0 minus 1 and 6 minus 5, or 1 minus 0 and 5 minus 6. Either one will work. So r equals the square root of 0 minus 1, negative 1 squared is 1. 1 squared is 1. So r equals the square root of 2. Now, if you get a negative underneath there, you've done something wrong. You cannot have a negative radius. Okay? You can't have an imaginary radius. You can't have a negative out in front. You can't have a negative underneath. If you get a negative underneath, you have done something wrong. So if r is root 2, then r squared is just 2. So equals 2. So there's your equation of the circle. So you have to know, when do I square it? When do I take the square root? R versus r squared. You have to be able to keep that straight. Questions? All right, this one's similar. It just gives instead of giving us the diameter and we have to find the center, it actually gives us a center. So x minus negative 3 is x plus 3 squared. Y minus 9 squared. So we're going to have to find r. So we do it the exact same way we did the previous problem. If drawing a picture is helpful to you, then go ahead and do that. Negative 3, 9 is up here. 1, 4. It tells us that 1, 4 is on the circle. And we know that negative 3, 9 is the center. So we have to find the radius. Once we find the radius, we can square it to find r squared. So again, it's just the distance formula. R is going to be the square root of. Doesn't matter which one you pick first. Here's negative 3, 9. Here's 1, 4. Just pick one of them to be your x1 and y1. Pick one of the points to be your y1, y2. It doesn't matter. Or, sorry, x2, y2. So I'm going to say negative 3 minus 1 squared plus 9 minus 4 squared. Or you could have said 1 minus negative 3, 4 minus 9. Either way would have worked. So r equals negative 4 squared is positive 16. 5 squared is 25. R equals the square root of 41. The formula calls for r squared, so we square the square root of 41 and just get 41. Your homework today is going to be easy to do that. When you get to the quiz and everything's mixed up, you're going to have to remember that. So be sure you know the difference. Wednesday when you do your circles and ellipses, there's no notes for that particular section, but it's mixing circles and ellipses, so you have to know the difference between the two. Circles can equal 1, but don't always equal 1. Ellipses and hyperbolas always have to equal 1 to be in the correct form. All right, here it gives us the center and tangent to the line x equals 4. Now, this is not sine, cosine, and tangent. That's not what tangent means. Tangent's a vocabulary word from geometry. It means touches. so it touches the circle. I always think drawing a picture is very helpful. So if we plot the point -3, 1, and that's the center, and then we draw the line, x equals 4. So we know this circle touches that line. Okay? The center, it tells us, x minus -3 becomes +3 squared. Y minus 1 squared equals. Now here, we could do it the same way, but because we know the center and we know this line touches, we can count. This is x equals -3, this is x equals 4, so the distance from here to here is 7. It's just how far. It's not 1, it's not -1, there's not anything. It's how far is it from the middle to that line. It's a distance of 7 units. The -3 is just where it's located on the coordinate plane. Has nothing to do with a distance being negative. So since r is 7, r squared is 49. A picture isn't necessary, but it's very helpful. Makes it very, very easy to draw a little sketch. When you get to the problems given in sentences like this, they're not really word problems because they're not application. It's just giving you some information. Drawing a picture with ellipses and hyperbolas will really be helpful because once we get to ellipses and hyperbolas, they can be vertical, they can be horizontal, and the information given when you plot it will help you determine which direction those are. All right, solve the system algebraically, and then we're going to graph it. So when it says solve algebraically, before this you had substitution or elimination. Those were your options. When you did parabolas, you solved a system. You had 2 lines, said write a system, solve a system. Whenever you have 2 equations that aren't the same, you can't use elimination. Okay? There's no way for us to use elimination in this case, so we have to use substitution. That's our only method. So that just means we have to get either the x or the y by itself. It doesn't matter which one. Since the x is already positive, I'm going to bring that y over. You could bring the y and the 1 over. It doesn't matter which one you do. So I'm going to plug this. Now I'm going to substitute it into the other problem. If you substitute it into itself, you're just going to keep getting the same answer that's not correct. Once you get one of the equations by itself, and I would always suggest the line. It's going to be a lot easier than having a bunch of square roots in that problem and plus and minuses. It will make your life very difficult if you try to solve for x or y in the circle. Always do it in the line. So now that ends up being y plus 1 squared plus y squared equals 25. Now that we have one variable, we're able to solve. We can't solve it with 2 variables, but we can with 1. This does not mean y squared plus 1. This means y plus 1 times y plus 1. There's still too many of you trying to distribute a squared to a polynomial. That's not even a mathematical thing. So stop doing it, because you can't get anything right if you do that. So we have 2y squared, y, plus 2y, when we bring that over, minus 24 equals 0. I've noticed some people are trying to leave that 24 over on the other side and make up some kind of math thing that allows you to solve that. There's no such thing as a 24 product property rule. It's the 0 product property rule. So we can find the product on the left, set it equal to 0, and we can get the answer. If you have a y squared and a y, you have to do that. If that y wasn't there, we could solve using square roots. That works. But with a y squared and a y, the only option is to get it all on the same side and factor it. Now, because there's an equal sign, I can divide everything by 2. If there wasn't an equal sign there, if this wasn't here and I just said factor, you can't just randomly divide something by 2. Okay, if the answer is 10, you can't say, well, I don't like 10, I'm just going to divide it by 2. If it's 10 equals 2x, then we can divide everything by 2 because there's an equal sign. So we can make that y squared plus y minus 12 equals 0. It just makes it a lot easier to solve if you can get it to be lower numbers. So now, If you want to use the quadratic formula, you are more than welcome to do that. I would not do that. There's too much work involved. So we get y equals 3 and negative 4. That is not a coordinate point. Okay, when you have a circle and a line, we have a circle, the line could go through it. We have a circle, the line could touch it. We have a circle, the line could miss it. So we could have two solutions, one solution, or no solutions. Those are our only options for a circle and a line. 2, 1, or no solution. Here we're going to have two solutions. This tells us we're going to have an x value that goes with the 3 and an x value that goes with the negative 4. So now you use that equation, x minus y equals 1. We know what y is. X minus 3 equals 1, so x is 4. Same thing here, x minus y equals 1, x minus negative 4 equals 1, so x plus 4 equals 1, x equals negative 3. So there are your two answers. So it crosses twice. Once you get your two either x's or y's, and if we had solved for y in the original at the beginning, then we would have just got our two x values, and we would have solved for y at the end. So that's solving algebraically. Then it says and graph. So now we have to graph the circle and a line. So the circle has a center of 0, 0, and a radius of 5. So you go up and down 5, left and right 5. And you don't have to be a perfect circle drawer, but there's the circle. And then if we want to graph a line, x minus y equals 1, I just need to put it in y equals form. So bring the y over, x minus 1 equals y. Now I can graph a line very easily. The slope is, or the y-intercept is negative 1. The slope is 1, so up 1 over 1, down 1 over 1, and there's your line. Now my circle isn't perfect, so obviously it's not going to look exactly right. That's why we solve it using algebraically, because it's tough to solve graphically unless maybe you're given a picture of a graph and you can solve it. So 1, 2, 3, 4, 1, 2, 3. Notice if my circle was a little bit better, it would cross right there. And negative 3, negative 4. Again, if my circle was a little bit better, it would cross right there. So that's just showing a graph of it. So typically when we ask you to graph them, it's going to be algebraic. Another one of those, it gives you a line and a circle that just doesn't have a center of 0, 0. So, but we do it the same way. We plug this in for y. There's no need to move that around. Y is already solved for. So whenever you're given two different equations, meaning they're not both lines, they're both not circles. If they were both circles, we could do elimination possibly. If they're both lines, elimination is a possibility. But when we have a circle and a line, two different graphs, you have to use substitution. So this becomes x minus 5 squared plus negative x plus 1 minus 2 squared equals 50. So here, x squared minus 10x plus 25, because that is x minus 5 times x minus 5. There's no such thing as distributing a squared to a polynomial. And then the negative x plus 1, you might not be able to do that. Some of them you can do that in your head, but if you can't, negative x minus 1 squared is what that is, which is negative x minus 1 times negative x minus 1. All those negatives kind of confuse you a little bit. Just go back to FOIL. Negative x times negative x is x squared. Negative x times negative 1 is plus 1x. Negative 1 times negative x plus 1x. Negative 1 times negative 1 plus 1. So this becomes x squared plus 2x plus 1. Then we have minus 50 equals 0. So it's just a bunch of adding, subtracting, and multiplying. That's all we've done so far. We substituted, added, subtracted, and multiplied. And so now we just combine like terms. 2x squared minus 8x minus 24 equals 0. Because it's an equation, and we have a 2, an 8, and a 24, again, we can divide. Only because it's an equation can we do that. X squared minus 4x minus 12 equals 0. And now we can factor. Now we need factors of 12 that give us 4, which is 6 and 2, a minus 6, and a plus 2. So x equals 6 and negative 2. That is not the answer. Okay, that means we have two answers. Those are the x values. So now we have 6 something and negative 2 something. You plug that in back to the original problem. If you can do that in your head, terrific. If not, y equals negative x plus 1. Y equals negative 6 plus 1, which is negative 5. Same thing here. Y equals negative 2 plus 1. So that's equal to 2 plus 1, which is 3. And there are your two answers. That means that that line cut through that circle in those two different places. And if drawing a little sketch of it is helpful to you, then do that. If it doesn't tell you to graph it, you don't have to. But if it does, and like the square root of 50, we know what the square root of 49 is. The square root of 49 is 7, so the square root of 50 is going to be a little bit over 7. So we would just make our radius a little bit more than 7. And this last one is that point on that line, or on that circle. So the problem like this, it's just saying, here's a circle. Does the point negative 3, 4 lie on that circle? So the way you determine that is not by graphing it. You plug in negative 3 for x, you plug in 4 for y, and see if you get 9. So negative 3 plus 3 squared, 4 minus 1 squared. Negative 3 plus 3 is 0. 0 squared is 0. 4 minus 1 is 3. 3 squared is 9. 9 equals 9. That's not the answer. 9 equals 9. If I say, is this point on the circle, you don't answer me with 9 equals 9. You answer me with yes or no. So in this case, it's yes. If you had got 8 equals 9, then the answer would be no. Okay, so whenever it asks if something is